Hello my Pythagorean student. In this video we are going to show you a quick way to remember all three Pythagorean identities. Let's start with the Pythagorean theorem applied in right triangle. We know a squared plus b squared equals c squared, where a and b are the two legs of the right triangle and c is the hypotenuse. Now in our class we don't use a, b, c, we use x, y, and r. So again, x and y are the two legs of the right triangle and r is the hypotenuse. Since this is a unit circle, so we only use our r is always equal 1. So therefore we substitute. So therefore x squared will be cosine squared theta plus sine squared theta equal 1. Or you can do sine squared theta plus cosine squared theta equal 1. So this is what we have right here for the first Pythagorean identity. From here we'll be able to remember the rest of the Pythagorean identity, because there are two more. So it means we start with sine squared theta plus cosine theta equal 1, and you go ahead and divide sine squared theta for each one of the terms. So each one of the term, left side and the right side, we divide by sine squared theta, and then we are going to simplify. So the first fraction, sine squared theta divided by sine squared theta, will give us 1. Cosine squared theta divided by sine squared theta, we're using the quotient. So cosine divided by sine will be cotangent, and we put the exponent too. So it will give us cotangent square of theta. And then let's go to the right hand side of our equation. We have 1 divided by sine squared. We're using the reciprocal identity. So 1 over sine is cosecant. Since we have the exponents, will be cosecant squared. If you have noted that if you're using the so I want to say the guys go together. So it means that if I have cotangent or something cos on the left side, the right side is also cos too. So cotangent square on the left side, the right side will be cosecant square. Let's go to the other Pythagorean identity. So again, we start with the first identity, sine squared plus cosine squared equal 1. But now instead of divide by sine squared theta, you divide by cosine squared theta both sides. So on the left hand side, you divide by cosine squared theta for these two terms. The same thing on the right hand side. Then you are going to simplify. So here sine squared theta divided by cosine squared theta using the quotient identity. Sine divided by cosine tangent. So this can be tangent squared theta. Cosine squared divided by cosine squared is 1. 1 over cosine squared using the reciprocal. So 1 over cosine is secant. So this will be secant squared theta. So those are our three reciprocal identity. Now let's look at the following example. So here we given tangent of theta is a negative value. So we know that tangent is a tangent theta give us a negative value. So if you remember, we have 4 quadrant. We cannot pick quadrant number 1 or quadrant 3. So our angle theta have to be in quadrant 2 or 4. And then here we also know that sine of the angle theta or sine theta have to be a positive. So it means that we go ahead and eliminate one more. So now our angle theta will be in quadrant 2. So it means your cosine will be negative. So I'm just kind of logic so that I'm thinking it out loud so that you can see. So the question asks us to find sine and cosine of theta. So the first thing we have to do is that we are going to use because in given tangent, so we are going to use the Pythagorean identity that involves tangent. So we have tangent squared theta plus 1 equals secant squared theta. So we substitute tangent for negative a, but since we have the exponent, so negative a to the power 2 plus 1 equals secant square. Simplify the left hand side, we give us 65. And then we take square root both sides, so now we have two answers, plus minus square root of 65, but then at the end we only pick one because since we only told you that your angle theta will be in quadrant number 2. And then now we are going to use the reciprocal identity. So secant is 1 over cosine. So now you put secant at 1 over cosine equal plus minus square root of 65. And now we need to solve for cosine. So again, to solve for cosine, you can think about when you go ahead and multiply cosine to the left side, and then divide both sides by plus minus square root of 65. So now you will have 1. So just remember that we skip few steps here. First of all, you're not going to see this. You will see 1 over plus minus square root of 65. And then we cannot have square roots in our denominator. So we have to rationalize the denominator. So finally you end up with square roots of plus minus square root of 65 over 65. Now we say it out loud right here again. Tangent theta is sine over cosine. This is the cosine identity. And tangent theta for the given is a negative real numbers. And sine is a positive real number. So cosine must be negative, because if you have a positive divided by negative, and your cosine, which is your answer, will be a negative number. So now we said that cosine must be negative. So we found two answers. One is positive and one is negative. Now we will go ahead and eliminate the positive answer. So we say that cosine is negative square root of 65 over 65. So now we have one, or we found one answer. Next step, we are going to use the cosine identity to find sine. So we have tangent is sine over cosine, which is the cosine identity, and we substitute tangent for negative a. And we also substitute cosine for negative square root of 65 over 65, so that we can solve for sine. So now to solve for sine, we are going to multiply both sides by the negative square root of 65 over 65. And then on the left hand side, when you multiply two negative numbers, your answer will be a positive. So you have a times square root of 65 over 65. Now here we don't have to do the rationalize the denominator, because we don't have square roots in our denominator. Just make sure if you see square root in your denominator, then you have to do one more step, which is rationalize the denominator. And the last step, don't forget that we have to check our answer. Now when we check our answer, it will be wiser that you don't have to check with the given Pythagorean identity. So it means that you don't have to check with the tangent square plus 1 equals the secant square theta. You can check with either one of them. You have 3. So we go ahead and check with the sine square theta plus cosine square theta equal 1. And then we substitute sine for a square root of 65 over 65, and we square this. And then we substitute cosine for negative square root of 65 over 65, and don't forget to square it. And our question is that if we simplify, if we find the sum of these two rational numbers, the sum will be equal 1. So we do our math, and you can see right here that you add these two fractions with same denominator. So you just add the numerator. So 64 plus 1 is 65. So 65 divided by 65 will give us 1. So check. So we found the correct answer. Now make sure you write down your own summary for each one of the video that we presented here. And thank you so much for watching. Goodbye.